Hello, math magicians out there! We are going to do a wonderful thing today. We're going to learn about standard form. And there was great rejoicing. Yay. All right, more specifically, we're going to write and graph linear equations in standard form. So by way of introduction, let's read this, pause, and give yourself some time to consider it. So, Josiah wants to make a playlist with 20 songs on his handy-dandy device. He will select tracks from The Hobbit and Jurassic Park soundtracks. Determine two different combinations of tracks from each soundtrack. So if he grabs 10 from here, how many must he grab from here, etc. We're going to plot those two options. Then you're going to extend the line through the points. Lastly, can you use the line to find any meaningful points? And are there any inconsistencies with the graph compared to real life? So pause now and come back and check. So let's look at my options. From Jurassic Park, I chose 3, which means I have to have chosen 17 from Hobbit. From Jurassic Park 10, which means 10 remaining is from The Hobbit. So over here, 3, 17, notice down here says tracks from Jurassic Park. And then over here says tracks from The Hobbit. So 3, 17. This one here is at 10 and 10 from The Hobbit. So the next part says for us to connect the dots. So I'm going to go ahead and do that. And it's best to use a straight edge so that you get good and accurate results here. So I'm going corner to corner, freehand. Now the next question we're going to ask is, well, is there anything valuable we can get from this? And also, mathematically, when we ask to graph, most of the time teachers say, put the arrows at the end because the lines go on forever. So now, what valuable information can we get? Well, notice here, if I chose 5 songs from here, that means I have to choose 15 songs over here. So it does. This gives me extra points from which to choose. But what doesn't it give me? Well, notice this. What if I were to say right here, this point there? Well, tracking down to here, which means this is 13.5 tracks from Jurassic Park. And you say 13.5? That's a problem. Why? Because although you can listen to a part of a track, you can't actually select only half a track to add to a playlist, as far as I know. Another thing that we can't do is we can't have negative tracks. Sometimes negative works, like in going places, forward is positive, backwards is negative, or owing money is negative, but we can't have negative tracks here. So there are some strengths and weaknesses of this graph. So we're going to spend some time doing some review. Then we'll introduce the next topic of standard form and how it's used. So first off, slope-intercept form. Looks like this. Y equals mx plus b. Tell me y equals mx plus b. And m, when I'm graphing it, tells me how to move, and that's my slope. Okay? B tells me where to begin on the y-axis, and that's my y-intercept. So I like slope-intercept form because it helps with graphing for the most part. Graphing is a very straightforward option. Another thing that's very helpful with this is because this is often deals with rate right here, and this talks about your initial or original cost. So for example, you're going to buy a $300 device, and then every month you're going to pay $10 to connect it to the interwebs, right? Well, that's exactly what's here. My initial cost is $300. $10 per month goes here. So after 12 months, after 15 months or whatever, that's going to tell me how much I've paid. So it's good for problems like that. All right, vertical line and horizontal line. Remember, vertical is like how much vertical does a guy have, a basketball player? That means his hops, his ups. So vertical is an up and down line. So horizontal, like the horizon, where the ocean meets the sea. Motion is the sea. The ocean meets the sky, and you're all romantical. So vertical line always looks like this. It only crosses the x-axis. This is my x right here, and this is my y. So that means it has some value right there. So that means x has to be some value, but y isn't. There is no y, so we ignore it, right? In this case, we say it has no slope. Another way of saying that, it has undefined slope. Next, horizontal line, in contradistinction, crosses only the y-axis, which means only the y is represented here. And so we do have a y-intercept, hence the b. And the slope here is just 0. It's a flat line. like so. And the last thing by way of review is called point-slope form, and it looks like this. Minus y1 equals m times quantity x minus x1. What do these things mean? M, of course, is my slope, tells me how to move. And instead of a beginning b, starting with b, y1, x1, y1 is actually just any point on the line. Any point on the line. So instead of having a specific point, b, we have any point on the line. So this one's a little bit more flexible. But a positive thing about this one is that it's fairly simple to graph as well. And given 2 points, generally we use point-slope form. We don't have to, but that's generally what we do. So the last thing we're going to mention to you is called standard form. So let me describe standard form and then show you a context in which it can be used. So standard form looks like this. ax plus by equals c. And notice I'm intentionally making this uppercase and this one lowercase. So just by way of an example of what standard form might look like, 3x minus 4y equals 11. So what makes this standard form and not this? 3x equals 4y plus 11. How are they different? Well, a key thing here is all my letters are on this side, and my constant, my non-letter parts, are over there. So let's show that here. Over here are all my variables. In this case, I only have 2 of them. Over on this side are my constants. So remember, a constant is any number and just one constant. It could be 0, it could be 11, like in our example there. So number 1, I like that it sort of keeps ourselves organized. Here's my x's and y's, and here's my non-variables. Okay, next up here, we have a, b, and c. A, b, and c are important, and a, b, and c are integers. Let me define integers for us. Remember, integers are the types of numbers that look like this. -3, -2, -1, 0, 1, 2, go on forever. So notice what it is. It's like the counting numbers with 0 and their opposites, but it doesn't include fractions, no 0.1, no 1/2. So no fractions, no decimals, only the whole numbers with the 0 and with the opposites. Another thing that's often occurs here is that a is usually positive. Usually. I'm going to say that's an optional thing, but most of the time you're going to find that a is positive. All right, why do I like this one? Oh my goodness. This one shows us the x and the y intercepts fairly quickly. And that's helpful in graphing very fast. So we'll get to that in a second. It's also helpful in context like we're going to look at right now. A high school football team scores a total of 42 points by scoring touchdowns and field goals. Suppose each field goal is worth 3 points and each touchdown is worth 7 points. A. Let x represent the number of field goals and y represent the number of touchdowns. Write an equation that models the total points scored in the game. So as we're going through, let's start highlighting a couple things. Number 1, a total of 42 points. Generally speaking, total requires that I'm going to do something like add. And in the end, I'm going to get 42. So I'm going to add something together, and I'm going to get my total points. I'm going to substitute this in just a moment here. So that's the first part. Total points, and I use PTS as the abbreviation for points. Next, a field goal. A field goal is defined for us as, and let's see here. We've got field goals here is x, and we know that they're worth 3 points each. We'll get to that in a second. But notice here is number of points by field goal. I'm going to say FG for field goal. Now, I'm going to add that to however many touchdowns I get. But each touchdown has a certain value here too. So Y is my touchdowns. So number of points scored by touchdown. So TD for touchdown. Okay, so how do we calculate each one of these? Well, the number of points by a field goal is simply this. 3 points each times X. X is the number of field goals. Bring down the plus, And now let's only look at touchdown. Number of points by touchdown. Well, 7 points for each touchdown, and we're going to multiply that by the number of touchdowns we get. And we can actually substitute this next one straight in because we already know what the result is. We know that the total was 42 points. Here we go. So the last thing, so we actually did this here. This is my model. Then it represents. Usually we don't write the times there, so it's just 3x plus 7y equals 42. We're going to identify and interpret the x and y intercepts. Okay, so x and y intercepts look like this. What we do is to find the x-intercept, the key thing is that y equals 0. Let me just show you again on a graph. If I have some arbitrary graph right here, and this one right here is my y-intercept, try that again, x-intercept, that means that this is some value of a, but it doesn't go up or down. So that means the y value is 0. So when I say 3x plus 7 times 0 equals 42, that means 3x is equal to 42, which means x in the end is 14. What's that mean? Only field goals would be 14. If only field goals were scored, they did 14. Well, same thing over there. For the y-intercept, we need to plug in x equals 0. So 3 times 0 plus 7 times y is equal to 42. The 3 drops out, so we're left with 7y equals 42. And when I divide both sides by 7, I get 6. So what does that mean? Only touchdowns are 6. So there's two extremes. We scored all our points with only field goals. Here, we scored all our points with touchdowns. So the next page here, take a moment to try it. Your job is to come up with the same scenario. If you are running for class president, you have $30 to spend, you're making buttons and posters, what would be the model, and what do the x and y intercepts represent? Go. So here we see campaign buttons are $2 times the number of campaign buttons. $1 per poster times the number of posters equals $30 my budget, how much I've spent. So if you none of these, you only buy buttons, you can buy 15. If you only buy posters, that's 30.